Welcome back to Fanshawe College. Welcome back to the lab. Before we start our labs, let's go over the lab rules. Review the lab equipment and learn how to use the oscilloscope and the signal generator, which will be used in our future labs. Let's move on with the lab rules. The lab rules are: 1. Wear a face mask. 2. Wear safety glasses. 3. Wipe the station before your lab. 4. No food and drink. 5. Print out the lab instruction, which can be found in Fanshawe online. 6. Complete the preparation portion in the lab instruction. 7. Pay good attention during the lab. 8. Follow the instructions step by step. 9. Tidy up the station after the lab. 10. Wipe the station again before leaving the lab. Let's review the lab equipment. This is the standard lab setup in our lab. From bottom up, we have a DC power supply which provides DC voltages, an oscilloscope which will be used to measure waveforms, and a signal generator which generates different signals. We used the DC power supply last semester. Let's do a quick review of it. The DC power supply has 3 output channels. 1. Fixed 5 volts. 2. Adjustable 0 to 30 volts. 3. Adjustable 0 to 30 volts. For the 2 adjustable channels, there are 3 control knobs. 1. Voltage coarse tuning. 2. Voltage fine tuning. 3. Current limiting. Above each adjustable channel, there are 2 meter displays. 1. Output voltage. 2. Output current. Now let's learn how to use the oscilloscope. The oscilloscope measures voltage versus time waveforms. On the vertical axis, or y-axis, it shows the voltage. On the horizontal axis, or x-axis, it shows the time. The power button is hiding at the top left corner. You need to push it down to power up the oscilloscope. The oscilloscope has 2 input channels, channel 1 and channel 2. The knobs above each channel adjust the voltage settings. The next set of knobs are for the time settings. The last set of knob and buttons are for the trigger settings. Now let's look at the voltage measurement. Power up the oscilloscope by pushing down the power button. Connect a probe to channel 1. Connect a banana alligator cable to the output of the DC power supply. Red to positive, black to negative. Connect the DC voltage to the oscilloscope probe. Red to testing tip, black to reference tip. Adjust the channel 1 setting to display the voltage on the screen. On the DC power supply, turn the voltage coarse knob to adjust the output voltage. On the oscilloscope, check the waveform, which should change along with the voltage. The following video clip shows you the measured changing voltage. Now let's measure the voltage value. First, adjust the voltage settings properly. Coupling. DC. It should be set as DC most of the time. The only time you want to set it as AC is when you only want to measure the AC portion of the signal, not the real signal. Remember, set it as DC, not AC. Probe. Times 1 or times 10. This is to match with the setting on the physical probe. If the probe is set as times 1, set the oscilloscope probe as times 1. If the probe is set as times 10, set the oscilloscope probe as times 10. Above the channel 1 input, turn the bigger knob to adjust the voltage scaling. Here we set the voltage scaling as 5 volts per division. Use the smaller knob to move the vertical position. The number 1 here shows the 0 position of channel 1. How to measure the voltage value. The voltage equals to number of divisions multiplies the voltage scaling. Here the voltage is 2 divisions above 0. The voltage scaling is 5 volts per division. The measured voltage value is 2 multiplies 5 equals 10 volts. Now let's look at the time measurement on the horizontal axis, x-axis. We are using the calibration signal of the oscilloscope itself, which is a square wave with 5 volts amplitude and 1 kHz frequency. Now connect your probe to this calibration signal. If you cannot get a stable waveform on the screen, it might be your trigger setting. We will cover the trigger setting later. When you get a stable waveform, use the smaller knob to adjust the horizontal position. Use the bigger knob to adjust the time scaling. Here we have 250 microseconds per division. How to measure the time? The time equals to number of divisions multiplies the time scaling. For example, the period here has 4 divisions. The time scaling is 250 microseconds per division. The measured period equals 4 multiplies 250 equals 1000 microseconds, which is 1 millisecond. The frequency equals 1 over the period equals 1 over 1 millisecond equals 1 kilohertz. The measured result matches the signal specification. Now we look at the trigger function. If the waveform is not stable on the screen, adjust your trigger settings. Push the trigger menu button to show the trigger menu. Use these small buttons to choose the settings. Here we set the type as edge, source as channel 1, slope as rising, mode as auto, and coupling as DC. Use this knob to adjust the trigger level. On the display screen, the little arrow at the right edge shows the trigger level. The trigger level must be within the signal level to make the waveform stable. The following video clip shows you the effect of adjusting the trigger level. When the trigger level is out of the signal range, the waveform is unstable. Now we move the trigger level within the signal range, the waveform becomes stable. Now we are familiar with the oscilloscope. Let's move on to the signal generator. The signal generator provides different types of signal for using in the lab. Its output is a BNC connector at the right. These buttons determine the type of waveforms. Here we have square wave, triangle, and sine wave. This knob determines the amplitude of the signal. The frequency will be set by 2 parts. The buttons set the frequency range. The knob sets the frequency factor. The output frequency equals the factor multiplies the range. Now let's send the signal from the signal generator to the oscilloscope. Use a BNC alligator cable for the output of signal generator. Connect the output signal to the oscilloscope probe. Adjust the settings of the signal, waveform, amplitude, and frequency. Adjust the oscilloscope settings to display the waveform, voltage scaling and position, time scaling and position. Trigger settings. Then perform the measurement of 3 waveforms, triangle, square wave, and sine wave. First we set the signal as a triangle waveform. The frequency equals 1.0 multiplies 1 kHz equals 1 kHz. Here is the waveform on the oscilloscope. The measured period equals 4 divisions multiply 250 microseconds equals 1000 microseconds equals 1 millisecond. The frequency equals 1 over the period equals 1 over 1 millisecond equals 1 kHz, matching with the signal. Now we set the signal as a square wave. The frequency equals 1.0 multiply 1 kHz equals 1 kHz. Here is the waveform on the oscilloscope. The measured period equals 4 divisions multiply 250 microseconds, equals 1000 microseconds, equals 1 millisecond. The frequency equals 1 over the period, equals 1 over 1 millisecond, equals 1 kilohertz, matching with the signal. Finally, we set the signal as a sine wave. The frequency equals 0.6 multiply 100 Hz, equals 60 Hz. This is the frequency in our power system, which we are using every day. Here is the waveform on the oscilloscope. The measured period is close to 3.4 divisions multiply 5 milliseconds, equals 17 milliseconds. The frequency equals 1 over the period, is close to 1 over 17 milliseconds, equals 58.8 Hz, matching with the signal. In summary, we have learned how to use the oscilloscope and the signal generator. Now it's time for you to put your hands on and start practice. Thanks for watching.